Hello, how are you doing?
I'm good.
Okay, so great. We are going to record today's session. I'm Anil Kumar from Toronto, Canada, and here is my student. So why don't you introduce yourself?
I'm Jad, and I'm studying at the moment in Frankfurt, Germany, and doing IB.
Great. So Jad, what do you propose to do today in today's class?
Uh, there's maybe a past paper would be good.
That will be
Just like,
amazing. So do you have any past
yeah,
paper to work on?
yes, I do.
So why don't you share that? So you share the past paper. Let me
Okay.
put that sharing on. Multiple sharings. You share the test paper. I think it will be very beneficial for most of our viewers.
Yes. So, this is the past paper.
Right, right. We have already
I
solved
think,
these questions, right?
yeah, we've done one, two, three, four,
Probability, integration, and
five,
function of function, probability,
probability
expected
density.
value, right?
Yeah, and
Induction
we've
method
done,
for proof, correct.
yeah, and this is where we left off.
Perfect. So let's begin from, it seems, trigonometry, correct?
Yes.
So, question number 8. The function f and g are defined by f of x equals to cos x, where x is between 0 to pi by 2, g of x is tan x, where x is between 0 to pi by 2. The curve y equals to f of x, y equals to g of x intersect at a point P whose x coordinates is k, and k is between 0 to pi by 2. Okay. Show that cos square k equals to sine k. So we have to basically find the point of intersection k, right?
Yes.
So how should we do it? Basically, we are going to equate the two, right?
Yeah.
So we are given f of x and we are
It's
given g
co
of x, both should be equal.
yes.
F of x is cos x, g of x is tan x. Both are in pi by 2, so we'll find k in pi by 2, right? So tan x, basically, you could also write this as cos x equals to sin x over cos x, right? Cross
Yes.
multiply. Sin x. And of course, cos x is in the denominator, so x cannot be a value which will give cos x as 0, right? Infinite,
Yeah.
correct? Right. So to solve this equation, we can write cos square x as 1 minus sin square x, bringing sin x equals to sin x, correct? So now we can bring all the terms to one side. So we get sin square x plus sin x minus 1 equals to 0. So that should give you the solution for this question, right? Finding the value of k. Okay. Show that cos square x. Oh, we had to just show that cos square x
It
is
just equals. Yeah. I've
oh,
just
that we found here itself, right?
yeah.
Okay, okay. I was going further.
Okay.
Okay, so we have done the first part, which is cos square x is equal to sin x. We don't have
Yes.
to find k. That's surprising. Okay, great. So we'll leave it there. So we're done, right? Cos square x is sin x. We're done party.
Yes.
Let's move on. What is the next part? Can you please read?
Hence show that the tangent to the curve y equals fx at P and the tangent to the curve y equals g of x at P intersect at right angles.
So P is the point of intersection, and where we have
Yeah.
already shown that cos square k is cos square, I mean sin square k, correct?
Yes.
Hence, show that the tangent to the curves at P and tangent to the curve this at P intersect at right angles. So let's find the derivative, okay? So derivative of cos x is minus sin x. And the derivative of tan x is secant square x. Right?
Yes.
So now it says the curves f of x just intersect at a point P where x coordinate is k. So we found that at x coordinate k, cos square k is equal to sin square k. So x values we know, sin square k and cos square k. K is the point. And show that the tangents at this curve are also perpendicular, right? So we know x values are k, right, at P. So P is
Yes.
some point which is k and we don't know the y value. Let me write f of k, right? So at this point, the derivative will be minus sine k, and derivative for the other function will be, let me write k itself. Secant square k, correct. Now, we have to show that they are perpendicular. It means product of their derivative should be minus 1, right? Or they are negative.
Yeah.
So either way, we can do it. So let's do the product of these two. So if you multiply f of k with g of k, we get minus sine k times secant square k, which is 1 over cos square k. Is it okay?
Yes.
But we have just shown that cos square k is sine k, right?
Yeah.
So
So you
it will
can,
be minus sine k over sine k, right?
yeah.
Which is minus 1. So at that point, both the tangents will be meeting at right angles because the product of gradients is minus 1. Is that clear?
Oh, yes.
So that is how we are going to do part B.
Okay.
Okay, so what is part C for you?
Find the value of sine k. Give your answer in the form a plus b root b on c, where a is, I'm sorry, a and c are real numbers, and b is a real positive integer.
Let me clear the screen and see exactly what it is. Find the value of sine k. Give your answer in this, right? So we have to find the
Yeah.
value of sine k. Oh, now they are finding the value of sine k. We were trying to do it earlier. Okay,
Yeah.
okay. So we'll do that part now. So basically, cos square k equals to sine k, right?
Yes.
Cos square k is 1 minus sine square k. Bring to the right side gives me 0 equals to sine square k plus sine k minus 1, correct?
Yes.
So sine k will be what? Apply quadratic formula. Minus b
Hmm.
plus minus. So minus b is 1,
Hmm.
right? Because we are
Yeah.
taking sine k as our variable, right? So minus 1
Oh, okay.
plus or minus square root. B square minus 4ac. So b square is 1 minus 4ac means 4 times. Both are 1. This is minus 1, right? Over 2a.
Yeah.
A is 1. Minus 1 plus minus. So 1 plus 4 is 5. Square root 5 over 2. So that's what we get. What do we have to prove? A plus
A plus,
square root b over c, right?
yeah.
So A is minus 1,
And b is
B is
5,
5, and C is 2.
c is 2. All right.
So that's what you get. Is that clear?
Yes.
Great. So we can move on to the next question. Okay. It says question number 9. The following
Oh,
diagram shows parallelogram OABC with OA equals to A. So this is vector A. OC is C. And magnitude of C is 2 times magnitude of A. Okay.
yeah.
So this is twice, okay, magnitude wise. A is not equal to 0. Okay. The angle between O and OC is theta, where theta is between 0 to pi. It could be anything, 0 to pi. Point M is on AB such that AM is K times AB. K times AB. Okay. K is between 0 to 1.
Yeah.
OM dot MC, OM dot MC equals to 0. That means they're at right angles. Dot product is 0, right? So it is at right angle, as shown here, right?
Yes.
Express vector OM and MC in terms of A and C. Okay. So we have to express OM and MC in terms of A and C. Okay. So you can see from the vector diagram, we are also given this is K times AB, right?
Yes.
K times AB. But AB is same as C, right? OC, right? So we can write equals to OM equals to OA plus AM. So it is equals to OA is A plus AM is K times AM, AB, correct?
Yeah.
A plus AB is same as OC equals to K times C. OC is same as C, right? They are parallel. It's a parallelogram, right?
Yeah.
So OM is KA plus KC. So express OM. Now we have to look at MC. M to C in terms of A and C. So A and
Yeah.
C. A and C. So MC is, we can say C minus OM.
Yeah.
Is that okay? C minus OM we just found. A plus KC. Which is C minus A minus KC. You can write like this. We can write C 1 minus K minus A. You can write like this. So that becomes MC.
Yeah.
C minus 1 minus K minus A. Okay?
Okay.
Now what we want? Hence use the vectors method to show what? A magnitude A
And
square times this is equal to 0.
equals 0.
So cos theta means they're trying to find the dot product. Otherwise, you will not get this cos theta term, right?
Yeah.
Okay. So use the vector method to show that vector method, not cosine law, right? To show that a square times this is equal to 0. Okay, equal to 0. So basically, we just found the two vectors, OM and MC, right?
Yes.
So, and they are at right angle, so we can use this property, OM dot MC is 0. So OM is A plus KC for us, and this is C minus A minus KC. Okay?
Okay.
We could use that form, but I think this is easier to use. So write down. I'll have to erase this. So OM,
Yeah.
we are doing OM. What we found is A plus KC. And MC, C minus A minus KC. C minus, yeah. Okay. So we'll do dot product.
Okay.
So basically, we are going to do OM dot MC equals to 0. OM is A plus KC dot C minus A minus KC. And this is equal to 0. That's what we are going. Now, what is A dot C? A dot C is AC cos theta, right?
Yes.
Because they are theta is the angle between them. magnitude of A, magnitude of C, cos theta. And when we do A dot, so in this we have got terms A dot A also, which is the magnitude of A square, right? So let's, A dot C will be A dot, let me write A dot C, then A dot A, which is magnitude of A square, correct? And A dot minus KC will be again minus K times A dot C, right?
Yes.
Similarly, with KC, I'm going to multiply plus K times C square, magnitude of C square, minus K times A dot C, right?
Yeah.
And minus K square C square. That is what, right?
Yes.
So minus, that is also 2 times. So we got 2 times term here, right? That's okay. So A dot C is AC cos theta. So I'll not write I'll have to write magnitude AC cos theta. Okay. It will require a lot of space. Okay.
Yeah.
So I'm just trying to match the terms. A square is already there. So that one is in factored form. Minus 1 minus 2k, they have already taken as factored. Okay. So minus kc and minus kc is 2kc, right? So A dot C, I'm taking AC common, or let me rewrite. Minus this and these two terms, right? I'm combining.
Yeah.
You have minus 2kAC, right? Then we have magnitude of A square plus or minus k times uh, plus k times magnitude of C square minus k square magnitude of C square. This also I could combine C square with k minus kc common. Okay. So from here, what you could do is we can take A dot C as common, right?
Yeah.
And you get 1 minus 2k and minus absolute value of A square. And here we have kc common, magnitude C square common. You get 1 minus k here also. So basically, you have to work with this and you replace A dot C with magnitude of A, C cos theta. You should get that term.
Okay.
Yeah, there's a very less space to work with.
Yeah.
But it is like kind of algebraic manipulation, which should give you that result. Is that clear?
Yes.
So we'll kind of stop here.
Okay.
And yeah, we'll take up the next problem. What is the next question? Find
Find.
the range of values of theta such that there are two possible positions of M. Okay. Two possible positions of M really means that, for example, here, I could have symmetrical value. We could have M here also, right? Kind of.
Yeah.
Giving 90 degrees. So M is a point where the two lines from O and C, they intersect at right angles. That's what it is, correct?
Yes.
So hence use the vector method to find that. So we have that equation, which we
Yeah.
fully did not derive, but we'll
But
assume
we
that
can use it.
we can
Yeah.
use it. Find the range of values of theta such that there are two possible. So we'll use the given equation itself. You get the whole idea,
Yeah.
which is magnitude of A square. Is it multiplied by all are factors? Okay. Times 1 minus 2k, 1 minus 2k. And then we have another bracket, which is 2 cos theta minus 1 minus 2k equals to right. Now, for this given equation to be true, we could have 1 minus 2k equals to 0, right? So 1 minus 2k equals to 0 will give me 2k equals to 1 or k equals to half, correct?
Yeah.
So k equals to half. That is one condition.
Okay, so a circle with equation x squared plus y squared equals 9 has a center of 0, 0, and a radius of 3. A triangle PQR is inscribed in the circle with its vertices at P, negative 3, 0, Q, X, Y, and R, X, negative Y, where Q and R are variable points in the first and fourth quadrants respectively. This is shown in the following diagram. 4-point Q showed that y equals the root 9 minus squared.
X squared. Yeah, since we are given the equation of the circle, which is
X squared plus y squared equals 9.
we can isolate, right? So y squared equals to 9 minus x squared, correct?
Yeah.
9 minus x squared. Since we are looking for the value at q, it will be positive, right? Y value is positive for q, right? Y will be negative for r. Is that clear?
Yeah.
From
Yes.
the point.
Yes.
So for point q, show that y is 9 minus x squared. That's correct.
All right.
Hence, find the expression for area. So y is going to be y here and minus y here. Right? So minus of this value there, correct?
Yeah.
Hence, find the expression A, the area of this triangle. So this value is x. Okay. So height is 2y. Area is half base into height, right?
Yes.
Base is 2y. And height is 3 units and then x units, right? Correct?
Yeah.
Because points are x and y and x and minus y. So x on the right side, correct?
Yes.
So you can write down the area in terms of x because we know y is square root of 9 minus x squared.
All right. Yeah.
2 and 2 cancel, right? So y is square root of 9 minus x squared times 3 plus x. You get the whole idea?
Yes.
So that becomes an expression for area. The area of PQR in terms of x, correct?
Yes.
So we got the expression area as equals to square root of 9 minus x squared times 3 plus x. Now next part,
Show that dA dx equals
all this.
this. Yeah.
So we can find the derivative of this dA dx. Use the product rule, right? So derivative of first part will be 1 half times with the square root comes in the denominator, right?
Yeah.
Times derivative of this minus 2x. Is it clear? Times
Yes.
3 plus x. Plus derivative of 3 plus x is 1. We get square root of 9 minus x squared. Is it clear?
Yes.
So that becomes the derivative. We can take 9 minus x squared in the denominator as common. Cross multiply, correct?
Yes.
We can do it on the top. So dA dx. Simplify. So we can take 2 and 2 cancel. Let me cancel this, right? So minus x is there. Square root of 9 minus x squared. Here we have minus x and times 3 plus x. And here we have plus. When you multiply, it becomes 9 minus x squared, correct?
Yeah.
Now, when you open the bracket, 9 minus x squared, 9 is there and x squared is there. X times x. So we'll just simplify this. Minus 3x minus x squared plus 9 minus x squared, correct?
Yep.
Over square root of 9 minus x squared. So minus x squared is minus 2x squared. So we get that term. Minus 3x is already there, right? And 9 is also there, correct?
Yeah.
Get our expression, which is 9 minus 3x minus 2x squared.
Yeah.
Over square root of 9 minus x squared. Correct? Just rearrange, you get this term.
Yes.
So that's clear.
Yep.
Any doubt?
Nope.
Right. Now it says hence or otherwise, find y coordinate of R such that A is a maximum. Area is maximum. Okay. So area will be maximum and this is 0, right? So equate the numerator to 0. So we have got 9 minus 3x minus 2x. So you can write this as minus 2x squared minus 3x plus 9 equals to 0, correct?
Yeah.
So to find the value where it will be maximum, you can write derivative is equal to 0. So that will be minus b by 2a, right? So that will be at x equals to minus b by 2a means 3 over 2 times a, 4. Minus b minus of this. So it will be at minus b by 2a will give me, or we can factor 9 times 2 is, 16, 18, right?
18.
And
Yeah.
18, 6 times 3 is 18, so you can factor, right? So we can take
Yeah.
minus 2x squared. So this becomes plus, because I took minus outside, right?
Yes.
So we get plus 6x minus 3x. And this becomes minus 9. So you can factor this. So you get 2x common minus 2x common. I mean, square bracket is better. And x plus 3. Here we got minus 3 common, x plus 3. So x plus 3 is common factor. And we get x plus 3 is common. We get 2x minus 3. Minus is also common, correct? So we factored this, right?
Yeah.
So we are looking for a positive value. So x is equals to 3 by 2. This
Okay.
the other value is x equals to minus 3, but it is on the right side. So we'll take
Yeah.
x equals to 3 by 2. Hence, otherwise find the y coordinate of R. So when x is 3 by 2,
It's
we can find the
it's
y
just
coordinate by plugging it y equals to
yeah.
0 to 9 minus x, right?
Exactly.
So that should give you the answer. 3 by 2, 2 square, 4 times 9, 36. 36 minus 9,
Yes.
25. So 5 over 2. 5 by 2 will be. We can do that work, right?
Yeah.
9 minus square root. 2 square is 4. So 9 by 4. So 9 is common factor. You can take 9 common, right? 4 also, you can take 3 by 2 common factor outside.
Yes.
So this gets multiplied by 4. 4 minus 1. 4 minus 3 square root. We'll redo it. We're just making some room here.
Yeah.
So y value is equals to square root of 9 times 4, 36, minus 9, 4, which is 25. No, 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 not 25. If I take away 10, then it is 26, 9 is 27, okay.
And then, yeah, divide by 4 on 4. Okay.
So 10, so this is 9,
Sure.
3 by 2 and
Right.
square root 3.
Yeah.
That is what I was getting earlier, so I thought.
Yeah.
So please, that is the value of y. So that is how you're going to solve this question. A lot of work, a lot of algebra, right?
Yeah. We have 2 more. You can do one
Just
since
see
you
that
won't have
question.
to.
What is it saying?
Which
Complex number?
one? This one?
Before this, yeah.
Yeah.
So it says, consider the complex number u equals to minus 1 plus square root 3i. By
Yes.
finding the modulus and argument of u, show that u equals to 2 e to the power of I 2 pi by 3. So when you say modulus and argument, so basically let's try to understand this complex number. It is minus 1 plus square root 3, right? I.
Yeah.
So minus 1 here, square root 3i, let's say here. So that is the angle. Do you understand?
Yes.
And this is like minus 1, this is square root 3. So we can find the modulus, which is a square plus b square square root. And then the angle by tan theta, right?
Yeah.
So modulus of u will be equal to 1 square plus square root 3 square.
Sure.
Is 2. So
That's,
that part is correct. 2 is correct, right?
yeah.
And the angle we want 2 pi by 3. So tan theta. So we want minus square root 3 by 1. So which is 2 pi by 3, right?
Yeah.
So we get this expression. So 2 is the magnitude and the angle theta is 2 pi by 3. So you could write this as e to the power 2 times e to the power of minus I 2 pi by 3.
Yeah. Wait, is it minus?
Yeah, because angle was 2 pi by 3, right? No,
Yeah.
not minus. Angle is, sorry,
Yeah.
I
Okay.
2 pi by 3.
Yeah.
Well, erase this part. So that part is okay done. So there are a couple ways doing it. This is, they suggested, by finding modulus and argument, you show this. Okay.
Yeah. Okay.
Part B is find the smallest positive integer n such that u to the power of n is a real number. So when you say it is 2 e to the power of I 2 pi by 3, right? Now,
Yes.
for real numbers means that sine theta part is 0, right? Sine theta part is 0, right? So when is sine
Yeah.
theta 0?
What?
Sine,
What?
sorry, when is, so sine theta part is
Sin is, yeah, so it's
0 pi to, sine theta is like 0 pi to pi, correct?
yes.
So it is 2 pi by 3. To make it 0, it will be n will be, because
In
n pi, right? I
Yes.
to n pi by 3. So n should be 3. Then we get 2 pi. You see that?
Yeah.
So, so this n will be 3.
Okay.
Summarize today's learnings.
So we started with we finished the induction. We started with the question about the trig one with where we had to prove that cos squared k equaled sine k. And then we did a few trig identities, and then we just had to find the value of sine k. Then we had a question with it is kind of a vector with a parallelogram. We did dot product to, and there was a few questions there, like find this, I think this plus this in terms of A and C, like express OM and MC in terms of A and C. And then we did we there was another question where there was a circle and a triangle, and then we had to find
Area of the
the
triangle
area
and
of the triangle.
coordinates to be found.
Yeah.
Right. And then we had a question on complex
Then
number.
we
Yeah,
yeah.
so quite a few questions we have done. That's a good variety. And before
Yes.
that, also we did a couple of questions. So I hope with that you got a good review, and we'll continue with this
Yeah.
review in our next class. So we
All
had a
right.
few more questions on trigonometry to be done, right? Which we
Yes.
take up in the next class. Okay. So
Okay.
end the class now here. Okay. Thank
Thank
you.
you.
Bye. All the best. Also check my book, Crack the Numbers, coming soon.
Who is this book for? Middle and high school students who want to go beyond the classroom? Future STEM leaders looking to develop problem-solving and analytical skills? Anyone who loves math and wants to see its real-world applications in AI, physics, and engineering.
Are you ready to explore the mathematics of the future?
Crack the Numbers for future STEM leaders. Sharpen your skills, shape the future. Available soon. Visit our website to pre-order your copy and unlock your mathematical potential today.